In the morning, I wrote a blog on memory and explained why it is important to not just store and retrieve the memory information, but it is also important to store the the cognitive terrain or the thought trajectory when the outcome was created by the agent or the language model, and how important it is to extract that cognitive terrain or that thought trajectory for a similar question. Langmem implemented this approach or this technique of extracting the thought trajectory as an episodic memory and then resurface it when a similar question is asked, right? And how Langmem is doing it, that's what we will see through an example. So Langmem also gave an example here where a pydantic object, the episode was created as a pydantic object, which, think about, this is the schema of the memory that you want to extract, right? And in this schema of the memory, you will include the observation, the thoughts, the action, and the result that can be extracted based on the conversation that the language model or the agent has done so far, right? And then once this memory is stored, this episode is stored based on another conversation, based on, let's say, another question, should be able to search my memory and map the new similar question to a episode that I have stored earlier, bring it back, give that episode as a context to the agent to answer the new question, right? That is in nutshell how the episodic memory works, right? What I did is I also created the episode, the schema. I took the same schema from the Langmem example, did not change anything here. This is I'm telling, like, when I'll send the conversation history to this memory agent, which may be the last node of a Langgraph multi-agents, like if I create a multi-agent system using Langgraph, the last node can take all the conversation that happened as part of the session, and then I'm asking that component to extract the context and setup, what happened, right? The observation, the thoughts, the internal reasoning process and observations of the agent in the episode that let it arrive at the correct action and result, right? What action was taken, what result, the outcome that was created, right? That is what I'm going to extract, right? So how I simulated this is, so I created a in-memory store to persist this in memory so that I can retrieve it from the memory store. In production, you might use a more persistent store. There are ways you can create a persistent store, like you can create a PostgreSQL memory store or a SQLite memory store or a MySQL memory store as well, right? But this is where I am instantiating the memory store manager with OpenAI GPT-4o. I'm creating a namespace episodes. This is where I'm giving the schema to the memory manager, saying, use this schema to extract the memory components, right? So this is the schema of my episode, right? And you can change your schema, right? The instruction that is I'm giving, extract exceptional examples of noteworthy problem-solving scenarios, including what made them effective, right? And then when this is the app, right? Where when a question comes, first I am doing a search in the store, right? To see what memory or what episodes that I have stored in the memory matches with my query, right? I'm getting the first match, right? I can say, give me the first 2 or 3 episodes also, right? But here I'm getting the first one, right? And then I'm reconstructing my system message or the system prompt, because there may be multiple episodes. So for each episode, I am providing the observation, thought, action, and result, which is part of that schema of the episode, as a context, as an episodic context to the LLM to answer the question, right? Finally, this is where I invoke the question, but the previous episode of a similar question, how it's solved, is also I provide as part of the system message. To simulate this, I hard-coded some conversation, and this is a text to SQL type of use case, where I said, can you help me get the names of all customers who placed orders in January, right? Let's say at that time, the assistant said, okay, assuming you have a table called customers and another called orders with a customer ID column linking them and orders as order date column, you can use the following SQL. Let's say this was the output. And then the user said, thanks, that helps, right? I'll try it out, right? And I do an app.invoke, right? So this will kind of like, although like this is, I simulated it, right? This part doesn't make much sense, but this is where I am providing these messages. This conversation is going here, right? And I am asking the memory manager, right? If you remember, this memory manager is what I created earlier. I created it as here, right? I created a memory manager with GPT-4o. The namespace where I want to store it is episodes, right? And I'm giving this conversation history and asking it to store this interaction as an episode, following the episode schema that I mentioned, right? And then, okay, in the first conversation, there is no episodes, there is no memory. So it will just store this, right? Then second time when I ask, can you help me get the names of all customers who placed orders in February, right? Earlier it was January, right? Now I'm asking in February. We'll see that it will match that episode, bring it back as an episode, and then put it into the system prompt and ask the question to the LLM so that it can use that, or it can remember what it did in the previous episode, which was the same question asked for January, but this time it is February, right? Let me run this. It will be more clear when I run this, right? So I put some prints to explain it. So first time like it is, I'm just simulating. So I just gave those conversations. So the first one doesn't make sense. But the second time, my question was, can you help me get the names of all customers who placed orders in February, right? This is what then it brought from the episodic memory. So in the episode 1, so when the first time I gave those conversation, it extracted this from this content, it extracted this as its episodic memory. Like the user ask was a user requested help to retrieve names of customer who placed orders in January using SQL. The necessary database tables, customer and orders were assumed to be present, linked to a customer ID with order date, being a date column in orders. Then the thought is I need to formulate a SQL query that correctly joins the customers and orders. And the final response that it gave in the previous interaction is I provide the following SQL query, right? Select, right, this is a query, and the user expressed gratitude and intended to try out the process query, right? That was the previous interaction, right? So it has a feedback from the user also that it is fine, right? Now it is using that as a episode, and the new question is, can you help me get names of all the place orders in February? Sure to retrieve. So now it is using the previous episode also as a context to create the SQL for the February, right? And since that episode is almost similar to what we have asked, now it will be more consistent and more accurate in answering the question, right? That is the applicability of episodic memory in the memory architecture. That's all I wanted to show. Thank you.